Hey guys, thanks for watching. This is the third video in a series, Why the Storage Matters for Hyperconverged Systems. So let's jump right into it. We'll have just a recap of our last deck. So switching on over. Again, HyperFlex does things substantially different right in this phase, right? We're not writing to a local cache and then replicating out to the different nodes in the system, right? So we're chunking the data kind of like this. And replicating that data across the entire network at the same time, leveraging cache in all the systems. So again, that's just a quick review of our last video. Moving along, so why do we do this? The whole idea really is to get consistency in the environment so that VM1 is going to have the same performance as VM25 on some other node off in the cluster, right? So you're not going to end up with an environment that's scattershot all over the place. So you're not going to have nodes, in other words, that have very high performance and then very low performance in other nodes. So you don't have to guess about where do I need to place my VMs. You don't have to think about it. You just put your VM wherever you want within the cluster, and they'll get the same performance across all the nodes. So that also has ramifications of how you move those VMs around and how you manage that in a failure scenario and so on. So again, HyperFlex uses the new log structured filed system, right? So it's designated for distributed scale-out storage, or it's not designated, but designed for scale-out storage specifically. And it's got inline dedupe and compression. You don't turn it off. There's no penalty to use it. It's just on all the time, whether the app can use that feature or not. So there's no guessing. Again, you don't have to manage it per volume or per VM or anything like that. And then superior flash performance is another side benefit to that. So let's just talk about networking a little bit. Networking is fundamental to the performance of HyperFlex because the data is striped across the entire network. As you can see here, you've got two FIs in the environment, and those FIs run at 10 or 40 gig. So they're very high performance. They allow you to virtualize the LAN. So you've got VLANs for storage, for management, for VM LANs, for vMotion. Pretty standard stuff, but on top of that, the VLAN for storage is specifically set up for QoS. That's automatic in the whole setup process. You don't have to manage that. It just happens so that there's no guesswork. The network is set up correctly every single time, right? So this is just another way to take a look at it. These are your FIs up at the top. Every single one of your nodes would have two connections to those FIs. You've got your VIC inside of the server. And that VIC allows you to create virtual interfaces. So virtual networks bonded together for your management VM, for your storage data, for VM networks and so on, right? So that's really one of the major advantages that HyperFlex has. There's no guessing about the performance of the network. It's not left to chance. It's not left to guesswork, right? And that's really what corporations are looking for. They don't want guesswork. They just want it to work every time. So that's really kind of a short, dirty look at networking within HyperFlex. Hopefully that gives you some ideas about what you might want to look into deeper. I'm going to have links to white papers and the other documents that I use to pull some of this together with, so that you can more wholly understand how HyperFlex is brought together and what it brings to the customer. Our next video is going to go into some of the management interfaces, and I'm going to show you just how easy it is to manage these environments